All right, talking about the domain of a function, the domain is what values we can plug in for x. All right, what are we allowed to plug in for x? So if we deal with this, if we look at this first example here, x squared minus 4, what numbers can you not have in the denominator? You can't have 0. So if we had this, x squared minus 4 could be anything you wanted, except for it couldn't be 0. So we would find all the things that make the 0 and say, nope, that's not going to work. So in this instance, we would say x minus 2, x plus 2. So x equals 2 or negative 2 would turn the denominator into 0. We don't want that, so we're going to say x can't be 2 or negative 2. So another way of saying that would be all real numbers other than x minus 2, which is what it says right here, other than x equals plus 2 or negative 2. So other situation that comes up quite a bit here is the square root. You can't have negative numbers under the square root. X has to be a positive or 0. All right? And so those are our domains. What can the x values be? So let's go ahead and find the domain of each function here. For a, they actually spell out what we've going on, so we just need our x values. So for a, our domain, and you can use your fun little scripty bracket, all of your x values, negative 3, negative 1, 0, 2, and 4. Just the x values. For b, we're going to look at b and say x could be anything we want except for we cannot have a 0 in the denominator. So x plus 5 cannot equal 0. So x cannot equal negative 5. The domain, all real numbers. Except for x does not equal negative 5. For c, the volume of a sphere, v equals 4/3 pi r cubed, we have to ask ourselves, what is the input? The input is the domain. The input here is the x value, and that's the r in this situation. R is being cubed. Is there anything that would not be allowed to be cubed? No, there is not. So for c, apologize, it keeps doing that. C, domain, all real numbers. And our last one, D. What do we know about square roots? It has to be greater than 0. So 4 minus 3x has got to be greater than or equal to 0. Sorry, just the part underneath has to be greater than or equal to 0. So let's solve for this. 4 has got to be greater than or equal to 3x. And so 4/3 has got to be greater than or equal to x. So our domain would be x has to be greater than or equal to 4/3. All real numbers greater than or equal to 4/3. Exercise 73. If you said that the domain is all real, except t cannot be 0, you are 100% correct. We cannot have 0 in the denominator, so t can be anything except for 0. All right, here we go. Example 8, dimensions of a container. You work in the marketing department of a soft drink company and are experimenting with a new can for iced tea that is slightly narrower and taller than a standard can. For your experimental can, the ratio of the height to the radius is 4. So height to radius is 4:1. All right, write the volume of the can as a function of the radius r. What we want here is v equals and r on the other side. So let's remember what our formula is for the volume of a can. The volume of a can is pi r squared h. If you didn't remember that, that's all right, but that is the formula for the volume of a sphere. I'm sorry, not a sphere. The volume of a, what is the name of this shape? Of a can. You can remind me next class what the shape is. That'll prove you watched the video. In any case, we need only r over here and not h. We have to get rid of h. So we'll go back to our original setup here and see if we can get h by itself. If we multiply both sides by r, we'll have h equals 4r. So back in problem A, everywhere we see h, we're going to replace it with 4r, and we'll have the volume is pi r cubed, and we stick that 4 out in front. So the volume would be 4 pi r cubed. If we wanted to do the same thing with volume as a function of height, v equals pi r squared h. That means that we only want h in our final answer. Got to get rid of the r. Let's get r by itself here. We could do this and divide by 4. H over 4 equals r. Let's substitute it in. And our final answer would be, we've got pi, we've got h cubed, and 4 squared is going to be 16, and we're going to have that in the denominator. All right, let's see if you can come up with this answer on your own for problem 87. Write the area of a square as a function of its perimeter, p. All right, let's get a couple of things here. Area is length times width, and since it's a square, length squared or base squared, anything like that, in a square, perimeter is 4L, add up all 4 sides, and so we want a function, the area as a function of p, so our final answer can only have the letter p in it. We know that p is 4L. Solving for L, we can say that p over 4 equals L. So let's substitute in. P over 4 squared, the area would be p squared over 16.